The usual method of connecting the gauges and lead wires together into a bridge circuit is used by soft soldering. Conventional procedures use a soldering pencil, solder, and a fluxing agent. While a comprehensive treatment of soldering technology is beyond the scope of this video, you can check out Dr. Barkey's video for more information on that. Some important aspects of transducer wiring can be outlined as followed. 1. Items to be soldered must be clean, free of oxidation, and free from adhesive or other films. 2. Join the wires to the gauge tabs using additional flux if necessary. Connections should form smooth, shiny pillars of solder without spikes or round lumps. 3. Inter-gauge wiring should be symmetrically arranged and of the same length from gauge to gauge. During the course of this lab, we will be explaining how to use a transducer. A transducer is a device that is used to convert a physical quantity into its corresponding electrical signal. In most of the electrical systems, the input signal will not be an electrical signal. It will be a non-electrical signal. In this lab, the input will be a weight. This will have to be converted into its corresponding electrical signal if its value is to be measured using electrical methods, which we will do.
As previously mentioned, we already have our strain gauges set up. So we take our cantilever beam and we securely clamp it to the edge of the table.
So we now need to connect the wires to the strain recorder. The black wire is going to go into the positive P terminal. The white wire for the signal is going to go into the negative S terminal. And the red wire is going to go into the negative P terminal. So first we need to make sure everything's set up correctly. So we're going to go into the menu on the strain recorder, and the first thing we're going to do is select the bridge type. In order for this to function properly, we need to have a half bridge set up. The second thing we need to do is to make sure we're in units of pounds. So under gauge factor / scaling, we can make sure that channel 1 is set up in units of pounds.
When you finally have it set up, the gauge will not read 0. So to balance it out, you click balance, and then balance again, and it'll auto balance for you. Then once it's done, you hit record to save it. And once the setup is saved, it will read 0. When you're in the lab, make sure you're wearing closed-toed shoes. So when you put the weight on the cantilever beam, make sure your feet are out of the way so in case the weight falls, you don't crush your feet. Now, once you place the weight on, this will not be calibrated correctly. We place a 1 pound weight on and it doesn't read 1 pound. To change this, you hit K for scaling. To calculate the scaling factor, you take the weight, so 0.7, and you multiply it by the current scaling factor, 6.286. In this case, it's equal to 4.286. Once done, you change it and it'll read the 1 pound weight. To double check that this is accurate, you place a 2 pound weight while still making sure your feet are out of the way. And then it still reads 2 pounds. So therefore it's set up correctly. One of the benefits of a transducer is no matter where you place the weight along the beam, you'll get the same reading. So as you can see at the front of the beam it weighs 2.1 pounds. And at the end of the beam it weighs 2 pounds.